Good morning, all. Today we are going to discuss about the concept of correlation. Already we have discussed about the concept of convolution, and in convolution we have discussed about the linear convolution and also circular convolution. So when we are doing the linear convolution of the two sequences, then we can do it with the help of three methods. Same way we can do the circular convolution. There also we have got three methods. If we want to filter out the long duration sequence, then either you have to go with overlap add method or same method. So all those things we have discussed in the previous classes. So in today's class, we are going to discuss about the concept of correlation. So the term correlation is nothing but it is used for finding out the similarity between two different sequences, or otherwise this is used for finding out the similarity between the same sequence. Okay. So for example, if you are having the sequences as x of n and y of n, then the correlation of the two sequences can be represented as R. R represents correlation. XY represents cross correlation. That means correlation between two different sequences. X of n into y of n minus m. So here R x of y, R xy of m represents that correlation of the sequences x of n and y of n. And if the correlation is performed between two different sequences, that's what I have represented. If it has been done for the two different sequences x of n and y of n, then it is called as cross correlation. If the correlation has been performed between two different sequences, then it is called as cross correlation. And if the correlation is performed on the same sequence, then it is called as autocorrelation. So the autocorrelation can be represented as Rxx of m. So m represents the variable and it can be represented as x of n minus m. So this is nothing but autocorrelation. So cross correlation is nothing but we are doing the correlation between two different sequences. Autocorrelation is nothing but we are performing the correlation of same sequence. That's why it is called as autocorrelation. Now, next one, here we have to find out the number of elements in the output sequence. That is nothing but autocorrelation. For example, if x of n is having samples of n1 samples, n1 value, and y of n is having n2, then the number of elements in Rxy, that is nothing but cross correlation is nothing but n1 plus n2 minus 1. So the number of elements in the cross correlation of the sequence is nothing but n1 plus n2 minus 1. For example, if you are finding out the autocorrelation of x of n, then x of n is having n samples. Then the cross autocorrelation is nothing but 2n minus 1. Why? Because x of n it will have n and x of n it is having n samples. So 2 times. So 2 into n minus 1. So this is the way we have to find out the number of elements in the autocorrelation and cross correlation. Next one, we are going to see about the method of computing the correlation. How to find out the correlation between two sequences. So for that, it is same for autocorrelation and cross correlation. So mostly here we will, these type of problems you will get only in the 2 marks or otherwise in the 4 marks. So the matrix method, you just follow the matrix method and find out the answer. So when you're computing the correlation, just take x of n and y of n are the input sequences. Now the cross correlation is nothing but Rx of y. What you have to do is nothing but x of n directly you have to take. But when you are taking the value of y of n, you have to find out y of minus n. Then you have to perform the cross correlation. X of n value directly you can take as it is, but when you are taking the value of y of n, you have to fold the sequence. That is nothing but y of minus n. Now perform the correlation between x of n and y of n by using matrix method as usual. Okay. As usual, you have to follow the matrix method and you have to find out the autocorrelation. And when you are doing it in the matrix method, one sequence will be represented in a row and another sequence will be represented as a column. Same way, you just arrange the components. See here, x of n arranged here and y of minus n is arranged here. Now as usual, multiply these two, you will get this first cell value. Multiply these two, you will get the second cell value. Same way for others. Now what you have to do is nothing but you have to add the diagonal values. You have to add the diagonal values. So when you're adding it, you will get the output sequence of cross correlation. You will get the output sequence of cross correlation. So this is the way you have to find out the cross correlation or autocorrelation. For example, when you're finding out the autocorrelation, you will represent the value of x of n here. And here you will represent the value of x of minus n. So as usual, multiply the values, find out the answer and finally add the diagonals. That is nothing but autocorrelation. So mainly we will use the correlation for finding out the similarities between two different sequences, or otherwise it can be used for finding out the similarity in the same sequence. In both the cases we can use the correlation concept. Okay. So now we are going to see some of the examples for finding out the autocorrelation as well as for the cross correlation. Just see the first problem. Perform the cross correlation of the sequences x of n and y of n. Now we know that x of n value directly you have to take and y of n is 1.51. When you are taking y of minus n, what's the value you will have? Y of minus n will be equal to same value 1. Okay, so 1.51. That's the way you will have 1.51. 1 is common, so 1.5 and 1 you will have. Okay, 1.5 and 1. So this is the value you will get. Okay, that means the 0 value 1.5 and 1. You will have the value like this. Why? Because this is at 0, this is at 1 and 2. When you are finding out y of minus n, what will happen? Minus, this is minus 2, this is minus 1 and this is 0. Anyway, the value will be same, 1.5 and 1. The value will be same. Now, arrange the value of x of n here. Arrange the value of y of minus n here. X of n, what's the value? 1, 1, 2, 2. Y of minus n, what's the value? 1.5 and 1. Now multiply these two values, 1 into 1. Multiply these two values, 1 into 0.5. Multiply these two values, 1 into 1. Next one, 1 into 1. 1 into 0.5, 1 into 1. Next one, 2 into 1. 2 into 0.5, 2 into 1. Next one, 2 into 1. 2 into 0.5, 2 into 1. Now we have multiplied all the values. So what's the answer? You will get 1.5, 1, 1.5, 1, 2, 1, 2, 2, 1, 2. Now divide the diagonals. Now divide the diagonals. Okay. Now divide the diagonals in the matrix. You will have a separation like this. Now add these values. Add the values in the diagonal part. Add the values in the diagonal part. Now what's the value you will get? 1, 1.5, 3.5, 4, 3 and 2. So this is the cross correlation between the two sequences. This is the cross correlation between the two sequences. This is the way we have to find out the cross correlation between two sequences. Now, next problem. We are going to find out the autocorrelation of the sequence x of n equal to 1, 2, 3, 4. They then represent the value of 0, so you have to take it as first value as 0. Now x of n is available. X of n is available. What's the value now? 1, 2, 3, 4. What's the value of x of minus n now? You will have x of minus n equal to 4, 3, 2 and 1. Now perform the cross correlation between these two. X of n you arrange here 1, 2, 3, 4. Here x of minus n. What's the value? 4, 3, 2, 1. 4, 3, 2, 1. So now multiply it. What's the first value you will have? 4, 3, 2, 1. Second value 8, 6, 4, 2. Next one 12, 9, 6, 3. Next one 16, 12, 8 and 4. Now add the diagonals. Now add the diagonals. So what's the value you will have? You will get the value like this: 4, 11, 20, 16 plus 9, 25, plus 5, 30, again 20, 11, 4. So this is the answer of the autocorrelation between the sequences. So these values we have to add. These values we have to add. So that is nothing but autocorrelation of the sequences. So when you are doing the cross correlation, you have to do the cross correlation between x of n and y of n. And y of n, you have to find it as y of minus n. When you are doing the autocorrelation, you have to do it for the same sequence. One you have to take it as x of n and another one you have to take it as x of minus n. So that's the way you have to find out the cross correlation and autocorrelation. Okay. Same way, if you're having y of n, then you have to find out for y of n and y of minus n. Some of the problems they will ask you to find out the cross correlation between the two sequences, and also they may ask you to find out the autocorrelation of x of n and y of n. Okay. So you have to find out in such a way that you can able to find out the cross correlation as well as you have to find out the autocorrelation. Okay. Thank you.